All right. We're working on this in class today. Actually, you could wrap this up right now this weekend. It's a pretty easy piece and it's nice. We can clean up the way we started this whole lab. So, what we had done, we had broken down to here is we are actually finding the range of possible magnitudes consistent with the errors that we estimated. So I know that sounds fancy, but let me show you what's going on here. So every single person, what I'm doing in blue, you should be doing under your own calculation. You rewrite it, obviously, there's not going to be space, but you should first rewrite your opposite calculation just like this. Here was Margaret's group, but your group, whatever it is, Dennis's group, your group, put your numbers in there. Even if we said, oh, yours were crazy, it was wrong, it doesn't matter. Do this piece of it the same. So item 1, you want to have opposite. This is just a rearranged substitution of our TOA. So opposite equals tan of whatever angle you used times whatever base you used. Then underneath that, you're going to write opposite subscript min and then opposite subscript max. And you're going to actually do the same math setup over here. And so you're going to have tangent again, and you're going to have some angle, and you're going to have some base. Now, the point of this is to figure out if someone were to make not mistakes, but their measurements were to be exposed to all these different errors, what's the lowest possible height they could get? And then alternately, what's the highest possible height they can get? And the reason that this is reliable and reasonable is because it is possible that due to these sources of error, you ended up low on the angle due to these fluctuations, steadiness of the hand, the straw, etc. And if all of those were to compound, were to happen at once, which is possible, what would you have gotten? And then if all of them would happen the other way to maximize, what would you have gotten? So here's how it works. There are other ways to do this. There are more generic ways to approach this, but they're messy. The easiest thing for you to think of is if we want the opposite, so here's really our step 2. If you want the opposite to be the minimum, what needs to be true of the angle here and what needs to be true of the base here? Well, the minimum possible opposite will come from, obviously, the minimum possible base. You make that base smaller, the answer comes out smaller. Tangent you may not remember, so you can do a couple of test cases. You can take your calculator and you can plug in tangent of 20. That comes out to 0.364. Tangent of 30. 0.577. You can even do tangent of 60 to make sure there's no inversion at 45. 1.732. So as your angle goes up, your tangent goes up, the result of the tangent. So if we want to minimize our opposite here, our height, then we need to minimize the angle over here. Well, that's good to know. And then obviously come down here to the max. If you want to maximize your height, you got to maximize the angle and you have to maximize the base. All right, so what are we talking about? Well, we really have to find all of our sources of error, all the estimates we made, all the quantifications, and combine them. So we had 4 of them for the angles. 1, 2, 3, 4. Very easy. If someone were to essentially be subjected to the overestimate error here for all 4 of these at once, which is not impossible, you would have plus 0.5, plus 0.5, that's plus 1, plus 3, that's plus 1.3, plus 2.2. 1.3 plus 2.2 is 3.5. So based on our source of error, your angle could end up, now that's bigger, goes with the max, you could end up plus 3.5 degrees higher than what you would measure with a better piece of equipment in a better situation. These were all plus minuses, I believe. They were. So if you do the minuses, you could end up as much as 3.5 degrees below. So for the minimum one here, minus 3.5 degrees, you might end up 3.5 degrees below. Okay, fine. What you would have with better situation, better equipment, better setup, etc. Okay, so now what does that mean? Originally, Margaret's group said the angle was 45 degrees, but based on our quantification of sources of error, it could have actually been as low as 45 minus 3.5. It could have been as low as 41.5 degrees. It also could have been as high as 45 plus 3.5, 48.5 degrees. So though Margaret's group got 45 degrees, we don't know that that is actually what the angle was. Based on our sources of error, this is not make-believe stuff here. Based on our sources of error, the actual angle could have been as low as 41.5 or as high as 48.5. Fine. What about the base? Well, the base, we only went over two sources of error. And really, there could have been a couple others, but that's fine. These two are fine. So we're going to play the same game. This one is only 1 centimeter, and this one is 15 centimeters. So based on the source of error, you might be off by 0.15 plus 0.01, which is 0.16. Your base may actually be 0.16 meters bigger than what you measured, or it was all plus minus. It might be 0.16 smaller than what you measured. And so, in fact, though Margaret over here has 14.8 meters, it may have actually been 14.8 minus 0.16. That brings you to 14 point. See, this one's a little tricky. You guys probably went to the 100th. I don't know what your 100th was over here. So if you did go to the 100th, which by the way, you should have, in fact, you could have gone a little beyond that. So you should have a digit in here. I don't know what Margaret's was. Let's make up and just say it's 0. So you could be 14.80 minus 0.16. That's 14.64 meters. That's the smallest it might have actually been. Or 14.80 plus 0.16, it might have been as big as 14.96 meters. Okay, now we're getting somewhere. We aren't quite done as soon as we run this, but you'll see. Based on these two calculations now, here's our step 3. Let's run this. Based on these two calculations, the minimum possible opposite comes out to, you can do the numbers, 41.5 tangent. Let's see, tangent of 41.5. It's about 0.885 times 14.64. That means the minimum that the opposite could have been based on Margaret's group's measurements and the sources of error, and we're not done yet though, is 12.95 meters. This actually is not finalized yet, but based on this so far. And the maximum it could have been based on the measurements and the sources of error, 48.5, let's tangent that, times 14.96, you get 16.91 meters. Now, we're not actually fully done here because two of the angle issues that we chose to turn into height issues we haven't paid attention to yet, the two right here in the middle. We actually also said that on our final height, this was based on the levelness of the ground and your head thickness. Really, this affected the angle, but it's easier to think about it as a height measure. So the final height measure could have been affected here. You could have been plus or minus 0.15, and from the head thickness, it was just a plus 0.20. Okay? So let's come over here and see how this affects. Those just get put on the answer. Those just get put on the answer. So the minimum, this one could have been a non-issue at all. So it doesn't have to apply, the 0.20. So if we were to go down, the minimum would be 0.15 less than this. So really finalizing this here, the real minimum could have been minus 0.15 meters. And the real maximum could have been plus, not just the 0.15, but the 0.15, here it is, and the 0.20, which is 0.35, plus 0.35 meters. So our final now, this is our final. The minimum possible height based on Margaret's group's measurements and the sources of error 12.80 meters, unless I made a mistake with the math somewhere. The maximum possible height based on Margaret's group numbers, 16.91. So this is going to be 17 point. So what's that? 9 less than that. So it's going to be 26 meters. Now, again, possible I made a math error in here, but roughly this is the right thing. This is exceedingly useful. This is exceedingly useful. Now, by the way, each group, you got to have your own numbers. Margaret, you just got the hookup. Anyway, next time we'll do another group. Each group's going to have their own magnitudes in here. Each group's going to have their own angle that they used. Each group's going to have their own base that they used. Everyone, however, will use this same adjustment and this same adjustment. So we'll all have those same adjustments. It will lead to different angles in here and different bases in here because you started with different angles and bases. It'll have a different pre-height adjustment, altitude or height of the pole opposite right here as well, because they're based on different original magnitudes. But the adjustments we're making, let me color them in purple. Adjustment, adjustment, adjustment. Those are the same for everyone. You just then have to do the math and see what you come out to. This is exceedingly useful because this tells you that the best you can claim about your measurement of the height, that the height of the pole is in the range of 12.80 to 17.26. That's that bracket notation from math. Meters. That's the best you can claim. So if the actual height of the pole falls in here, you're good. However, notice the range. That's a pretty big range, which should concern you that your technique is not particularly accurate, which means if you really needed this to measure something and rely on it, well, I wouldn't have that much faith in your result because look at the range. If you really had to make, let's say, a ladder that reaches a window exactly for a fire escape, is this technique good enough? I don't know. You're looking at a 4.5 meter range here. I'm a little worried about that. But finish this part of the lab. Finish this part of the lab. Okay? And then Monday you'll bring it in and we'll just do a quick percent error rather on what I think the actual is. And we'll submit that, John. All right.